देता हूँ मैं। Check 1 2 mic test check 1 2 hello test check test check
Hello. A very good morning to one and all.
इस ग्रुप में ये तो हमारे लाट साहब लोग हैं जो CSR के साइंटिस्ट।
check hello
यहाँ
hello
से अनाउंस किया। नहीं कोई मैं फोन
check
Hello.
test check hello
हेलो
hello
मैडम थोड़ा
check
नीचे देख लो।
test check
नीचे
hello
भाग गई वो नीचे भाग गई।
hello
हम स्टेज पे थे एनीवे मैं कह रही हूँ आप ना वो जब रिजल्ट प्रिपेयर हो जाए और वो सब कुछ सर्टिफिकेट वगैरह लेके ना आप आ जाना बैक स्टेज।
आपका क्विज का रिजल्ट है ना,
check,
प्राइज
test,
भी
test,
सर्टिफिकेट
check,
भी।
hello.
प्राइस सर्टिफिकेट सब कुछ। हाँ, लेट हो सकता है, लेट की तो कोई गुंजाइश नहीं है।
I also request you all, if you're carrying cell phones, so kindly put it on a silent mode or switch it off so that the decorum of the event is maintained.
check 1 2. Hello, check test.
I request our school students to kindly maintain the discipline and please maintain silence in the auditorium. There's a lot of disturbance, there's a lot of noise. Kindly ask the students to maintain silence in this auditorium. Within a short while, we will begin with our program. So I request you all to please keep silence. Just a few moments more and our esteemed dignitaries will be here. I request our dear students to please maintain the silence. I also request our dear guests to please put your mobile on silent mode. I request the volunteers of the quiz competition to please help the students maintain silence in the auditorium. Walking down the aisle are our esteemed dignitaries, Professor V. Ram Gopal Rao, Fellow of IEEE, TWAS, INAE, INSA, IASC, NASI, Group Vice Chancellor, Birla Institute of Technology and Science. Accompanied with him is Professor Venu Gopalachanta, Director, CSIR-NPL, and Dr. Ritu Srivastav, Convener, 1 week, 1 lab, Senior Principal Scientist, CSIR-NPL. Can we give a huge round of applause to our esteemed dignitaries? I request you all to kindly be seated. I also request our Director, sir, to kindly accompany our dignitaries on the dais. I welcome you all on the dais. I request you all to kindly be seated. I request our dear gathering to please be seated. On the dais, we have our keynote speaker, respected Professor V. Ram Gopal Rao, Professor Venugopal Achanta, and Dr. Ritu Srivastava. Can we have a huge round of applause? The clear blue sky and the sun shining high. It is indeed a beautiful day as we commence today the 1 week, 1 lab campaign in CSIR-NPL. I, Dr. Sharon Jyotika Paul, welcome you all on this very auspicious occasion. What a beautiful time and great opportunity for the gathering to gain important insights on the campaign before the advent of this campaign, of this program. It is an absolute honor for us to have amongst us today Professor V. Ram Gopal Rao, who will bring forth the importance of this unique campaign during the keynote address. Before we begin today's program, we would like to acknowledge his presence. I request Ria to kindly come up with a token of delight and respect. Sir, we welcome you to this program, and it is indeed our honor to have you, and thank you for being a benevolent contribution to this event. We will now invoke the blessings of the Almighty with the lighting of the lamp. I request our honorable dignitaries to kindly proceed for the lamp lighting. I request the volunteers to kindly help with the lamp lighting. This act of kindling the lamp symbolizes the triumph of light over darkness, knowledge over ignorance. Asto ma sadgamya, tamso ma jyotirgamya, mrityor ma mritam gamya, which means we pray to the Almighty to lead us from evil into good, lead us from darkness and ignorance into light and knowledge, lead us from fear of death into knowledge of immortality. The lamp has been kindled and lightened. I request you all to give a huge round of applause as we commence the opening of this program. I thank our dignitaries for doing the honors. Now I humbly request our Director, CSIR-NPL, Professor Venu Gopalachanta, to kindly come and accord a ceremonial welcome to our august gathering and a venerated guest.
Okay, right. Good morning, everyone. Professor Ram Gopal Rao, thank you for accepting our invitation and coming here to deliver the keynote lecture. And Dr. Ritu Srivastava, who is convener of today's event as well as this entire 5-day program. So we'll have the formal inauguration after this talk because of the availability of our minister, whose idea is to have this 1 week for each of the laboratories. So we have a huge gathering of students, so I thought I'll introduce. You already have seen some videos. I thought I'll give you a brief glimpse of what NPL is. So when I came here about 22 months ago and I asked this question in the schools and colleges or wherever I went, like, so what is NPL to you? Each one gave a different answer, right? So I thought I'll show you like what NPL is all about, right? So some people said this was the place where the indelible ink, right? Election mein, we all know that ink dalte hai finger pe, right? So that ink was formulated at NPL and then Mysore paints, they make it, and we still use this in every election. Right? And some people said NPL is the preserver of original Indian constitution. आप में से बहुत सारे बच्चों को पता होगा कि हमारा वो ओरिजिनल कॉन्स्टिट्यूशन है, इंग्लिश और हिंदी में लिखा हुआ है, वो इट्स बेसिकली हैंड रिटन and even the calligraph, the paintings were all made by hand. So these are in Parliament Library, and NPL has the privilege to preserve these in special casings which were developed, right? And many of them, most of them know NPL as these. Who can guess what these are? The timekeepers. All the Marvel fans will know that we are the timekeepers of India, because the Indian Standard Time is given by NPL. Right. But there is a lot more which goes on in NPL, which is which I want to highlight today. Right. So we all know about this. These are the pyramids in Egypt. How these are built in thousands of years ago. Right. So if you look at the famous museums around the world, the big museums have this something called a cubit. This is an Egyptian cubit. This is a scale. If you see, each one is a finger, and each finger, if you look from here, is divided into 2 parts, 3 parts, 4 parts, and it goes into very fine division. Right? So these are needed to make any precise construction. So these are basic ingredients. Measurement of length is one of the basic ingredients with which you can make huge buildings, huge architectures. Right? So if you look in India, if you look at this is just a rock cut cave. There's nothing much great in it. It's just a hole drilled inside a rock face or a hill face. Right? But if you look at this one, there is double decker. And you also see these pillars. You see these rectangle windows or entrances which are there inside. So these are all the caves used by Buddhist monks. Right. What is interesting is these were made in 1st century BC. These are from Odisha. This is the Rani Ki Gufa. Right. And even more spectacular examples which we have is, for example, from Nalanda in Bihar. This is from 7th century BC to 1200 CE. So you see these nice structures which are cylindrical shaped, circular, and even these sloping, curved features and all that. If you look at the edges, you have these bricks of uniform size and shape and all that. These are possible because we also had these measuring tools. Right? So time, for example, on the corner here, so you have division of 1 second down to 10 power minus 7. And up to 10 power 22 seconds, we have these units in time. Similarly, we have these measuring scales. For example, these are markings which are made in a shell. Right? And also we had these weighing stones of all different sizes and dimensions. Right? So if you look at the Kautilya's book, way back in 1 BC around, so he has actually defined these 16 different types of balances. This is one such balance which is shown here. Okay. So, and one of the important things is he has recommended that government has to check every 4 years, every 4 months, sorry, whether the shopkeepers are using the right balances or not. So we need to have some legal system through which we measure. If you go to a shopkeeper, if you buy something, right? We want to go to a cloth shop and we want to buy 2 meters of cloth. Are we getting 2 meters? How do we know that? We are just blindly, we are not worried about getting cheated. We are just trusting that the shopkeeper is giving us 2 meters. But how can we trust this? There is a mechanism which goes on behind that. So that is the world quality infrastructure. If you look at it in the world, like so, there is always at the top is the National Metrology Institute. Each country has one designated institute. For India, NPL, the National Physical Laboratory, is the National Metrology Institute. And this coordinates with, for example, national standards body, like the Bureau of Indian Standards, which make these standards, sets up these paper standards. On paper, what should be, how you should measure, what you should measure, all these things are defined on paper by BIS. Then you have these accreditation bodies, for example, Quality Council of India, NABL, NABH, NABCB. So there are private laboratories and also regional reference standard laboratories under the legal metrology, which all will make sure that down at the shopkeeper, they are using these right weights, right measuring tools, right, so that the consumer is not cheated. Right? So these are all traced back to what we maintain here, what we set up at NPL and how and disseminate it. We make them available to be tested. Every equipment across the country can be tested across the facilities which are at NPL. So that is why this is the National Metrology Institute. Right? So it acts as a bridge. So I mentioned about how these are going down to the shopkeeper level, the primary standards, national standards which are at NPL. And NPL also has another mandate that if we are exporting to a different country, they should also accept that whatever we are saying, 1 ton of gehu, for example, right? Is it 1 ton or are we cheating by sending little less quantity? The other country should accept what our weights are, what we are sending, the quality and quantity. So they also have to accept the facilities which we have at NPL. So we do these intercomparisons with other countries and make sure that our measurement capabilities in the country are at par and are accepted by other countries. So we act like a bridge between the international community and also within the country for legal metrology purposes. Right. So these are the mandates given by Parliament. Right. Most recent, this is not the most recent, this is the most recent one, which is saying that this is from CSIR-NPL, which said that everybody in the country, all businesses, everybody has to take the time from NPL for everyday application. Right. So if you look at prototypes which we have at NPL, so we have this NPK, national prototype of kilogram, NPK 57, and we make copies of this and then make sure that it goes to the shopkeeper level. And this is international prototype for meter. These are platinum iridium materials which are very well preserved so that we can make copies of them. Right. At NPL, we have 6 divisions. So the first one is the physico-mechanical metrology, where we do force, temperature, length, mass, all the physical parameters are all set up here. And electrical electronics metrology, voltage, current, resistance, capacitance, all these electrical parameters are all under this. So you have this environment and biomedical metrology. So you have this Antarctica Maitri station to making these particle counters, calibration testing facilities for these pollution monitoring equipment, right? To more recent biomedical metrology, basically, for example, defibrillator. When somebody gets a heart attack, they give this shock. So that requires certain pulse and voltage and all that. So whether the equipment which is made in India or which we are importing, are they of the right, giving the right pulse or not? And similarly, infusion pumps for injections and other things, right? So these are all the facilities we have for testing and calibration. So another important activity is waste to wealth. We all talk about circular economy. So we are making fancy new devices, new equipment. But then after some time, these equipment die down, right? Like our iPads or whatever. Like, so there is certain lifetime for them. What do you do with the waste electronics or solar cells or plastic? So we have this waste to wealth where we see like how we can reuse, recycle those materials for different applications. We have a very good team on advanced materials in the materials in device metrology. Carbon materials is one strong group over many, many decades. So this is one example where the fuel tubes for compact high temperature nuclear reactors were made. And the reference materials is very important. So the quality of gold, for example, when we go to buy 22 karat gold, right? How do we know it is really 22 karat or not? Right? So we make these reference materials against which we can test what purity of materials we are getting. It need not be gold or silver, but it can be as simple as rice, water which we are drinking, water which we buy, or chemicals, right? Cement, oil, petrol, right? All these things, like we make reference materials and we make them available for different laboratories to check. And of course, the Indian Standard Time, there is a 6th division where we work on maintaining this primary standard, the Indian Standard Time, and then making it available for all the users. Right? So these are all the different stakeholders, different sectors to whom we cater to, from defense to, this is NABL testing laboratories, to aviation sector, textiles. So these are all the laboratories and industries whom we cater to and provide these calibration and testing services. So we have these, what is known as CMCs, calibration and measurement capabilities. Compared to the leaders, we have to increase these things. That's where we are working on to improve our measurement capabilities which are needed for our growing industry. Right. So just to show some examples, not just timekeepers, not just indelible ink, we also made these phosphors for monochrome and color TVs, which were transferred to the industry. If you ask your parents, these black and white TVs, so the phosphors for the screen, they were initially made at NPL and then transferred to the industry to make these TV sets locally. Right. So this is a SODAR. This is again made in 1973. So in 60s, like so from 1960s, we are one of the regional warning centers of the International Space Environment Services of URSI, is an international radio science organization. So this is one of the 20 facilities across the world. Right. So these are the BNDs which I mentioned about, reference materials. So the carbon composites, for example, one successful example is making these materials suitable for this cone in the, you have these extreme high temperatures when this missile or spacecraft is going, so you have extreme heat and conditions to which this has to sustain. So the material has been developed here and transferred to DRDO, and they make these. And these are materials for different applications. For example, this is you see for the polio patients. Then you have the fuel tubes, which I mentioned. So this is the 5-crystal X-ray diffractometer. These are equipments which are built at NPL long back. So this is superconducting magnets are another successful story here within the country they were made. And this is the Maitri station. There are some pictures of Antarctica stations. Right. And this is the time, this is the cesium fountain, one of the few countries in the world which has this cesium fountain facility. And these are pictures where this carbon paper for, these are bipolar plates for different applications. In this case, these are for fuel cell. Then this is waste to wealth, which I already showed. So this is a free air carbon dioxide enrichment. So there is a lot of negative reports which said that agriculture releases a lot of carbon dioxide into the environment, and that is causing these third world countries which are dependent on agriculture. So they're polluting more than the developed countries. So we need to study these, how much carbon dioxide is actually generated and what is the effect of that on the crop itself. So these are studies which are carried out. Right? And for the future, we are working on this so-called quantum metrology. So the 7 SI units, the International System of Units, are kilogram, meter, second, ampere, Kelvin, mole, and candela. So right now, we have direct measurements. So you have a kilogram, a prototype, you make copies of it, and then you use a 2-pan balance. You put the known weight on one side, and you put whatever unknown weight on the other side, you balance it by adding or subtracting the unknown weight. Right? So similarly, for length, you just measure using a measuring tape or a scale. But for the future, what we want to do is improve the accuracy with which we are measuring these things. So instead of measuring directly the kilogram, what we want to do is we measure these universal constants. So these constants have very fixed, precise values, as we know. So if we measure these Planck constant with very, very high precision, then our precision with which we can measure kilogram will improve drastically. So in the new definitions, we'll be measuring these, each of these universal constants so that our accuracy in measurement of the SI units will improve. Right? So we are setting up these facilities. So what you have visiting here today and over the next 4 days is you can visit our laboratories, you can interact with scientists, you can visit the NPL museum which is coming up. We can learn about metrology. Metrology is a science of high precision measurements. You have these material science, environmental science activities at NPL. So we have planned this 5-day event such that today is the inauguration at 12 o'clock. And then we have the student and teacher interaction where you can visit the labs. And tomorrow we have inauguration of the industry meet, which will go on for 3 days, 18th to 20th, where each day we are expecting about 20 industries. Then on 19th, we have metrology conclave, where our stakeholders, including BIS, QCI, then we have legal metrology, NABL laboratories, all these people will be there. On 20th, we have the R&D conclave and women in STEM. And 21st, we have the skill initiative. So I welcome you all to NPL. And we have the privilege to have Professor Ram Gopal Rao to give us a keynote lecture, and I welcome you all to this program. Thank you.
Thank you, sir, for sharing these valuable insights on the measurement standards and how NPL stands as a National Metrology Institute that is playing a vital role in the dissemination of these mandates, and also telling us about the innovative technologies that NPL is developing with futuristic perspectives. Thank you so much, sir. Without much ado, we will now enter into the keynote lecture. I am profusely elated to take this opportunity to introduce you all to our keynote speaker. He is a man of great accolades and honor and has distinguished works in numerous capacities. Professor V. Ram Gopal Rao is currently the Group Vice Chancellor for the Birla Institute of Technology and Science, campuses located in Pilani, Hyderabad, Goa, Dubai, and Mumbai. Prior to joining the BITS Group in 2023, Professor Rao has served as Director of IIT Delhi for 6 years and as a Chair Professor for Nanoelectronics at both IIT Bombay and IIT Delhi. Professor Rao is an internationally acclaimed nanoelectronics researcher with over 480 research papers and 50 patents, which include 20 US patents, and 15 of his patents have been licensed to industries for commercialization. Dr. Rao has been elected as Fellow of IEEE, a Fellow of the World Academy of Sciences, the Indian National Academy of Engineering, the Indian Academy of Sciences, the National Academy of Sciences, and the Indian National Science Academy. Professor Rao's research and leadership contributions have been recognized with over 35 awards and honors in the country and abroad. These include the Shanti Swarup Bhatnagar Prize in Engineering Sciences, Infosys Prize, IEEE EDS Education Award, and many more. He is a recipient of 3 honorary doctorates. He also serves as a chairman for multiple committees at the national level related to education, research, and innovative programs in India. We are indeed fortunate to hear him speak today on the topic entitled enabling deep tech innovation in Indian institutions, opportunities and challenges. I request our esteemed dignitaries to kindly proceed towards the front row as the keynote lecture would be delivered. And sir, we are eagerly waiting to hear from you. I humbly request you to come forward for the keynote address and the lecture. We invite you to the dais, sir.
Okay, thank you very much. So I see a lot of students, so and I think holding students' attention is much more difficult than holding the attention of elders. So let me try. But my talk, in fact, I haven't really kept it for students, but children. But I think I will also try to orient it to make it a little bit more interesting for them. So thank you for inviting me. I'm very happy to be here. See all my earlier colleagues and friends here. And so I will talk in general about the deep technology innovation and my own story, how I started attempting something like that and what I have been able to achieve and what we need to do in Indian academic institutions. So I have about 45 minutes as I realize. So I will try to stick to the time. And one thing which I personally believe, even when I was at IIT Delhi and IIT Bombay was, how do we start companies and how do we scale up these companies to make them unicorns. Unicorns are like a $1 billion valued kind of companies. And if you look at India, there are over 100 unicorns, 107 unicorns to be precise. I think there's a lot of noise, huh? So, hello, ma'am. They're all receiving something, so they're all very excited. So, I think, yeah. Yeah, I think if you can listen to me for 45 minutes, or not more than that. So, okay. So there are over 100 unicorns now, and which is very good. But one thing which I have as a complaint is there is not a single startup today, or not a single unicorn which is based on a deep technology product, and that is what I believe we need to change. We need more unicorns which are product based. So that is what we need to be able to do. And the current unicorns, I call them mostly the business model innovation. And while what we require now are also technology innovations, the deep technology product oriented innovations. And that is where I strongly believe academic institutions need to play a major role. And while we have been focusing on education and research in academia, in all leading institutions and laboratories, what I believe is missing to a very large extent is the innovation driven sort of research, the things which can become products at some point in time. So the innovation in my definition is always something which generates value for the research. While research is publishing papers, generating new knowledge, anything that utilizes this new knowledge and then makes or develops a kind of a product or any service which helps the people, that is what I would call the innovation. So generating value for research is therefore the innovation. Now the question is, how do we generate value for all the good research that is happening in the country? So that is what I have been personally, and even as the director at IIT Delhi, and now in my current role, I have been trying to bring about that kind of an innovation in our academic institutions. I will also talk a little bit about that. Just to talk about the Indian academia, we have over 1,000 universities right now, of which there are 135 which are the institutions of national importance, where you have all these IITs, IIMs, ISERs, all of them come under. So if you are also looking for the number of PhD students, doing PhD in India, it is well over 200,000, over 200,000 students are doing PhDs in all these institutions, and which is growing at almost like a 10% CAGR per year, and which is a pretty significant growth. So now we will have at least 230, 240,000, close to 250,000 PhD students in all these academic institutions. And what do the PhD students do? They usually publish papers, and a lot of good research happens through these PhD students. And another good thing, which oftentimes we don't realize or recognize coming from the IIT system is the gender ratio. Now in the higher education in India, there is an equal representation of boys and girls, or men and women. So 50% are women in the higher education system in India, which is a pretty good sign. In engineering, probably we need to have more women, but overall in higher education we have girls to boys ratio, which is 50-50. And if you also look at the R&D, I told you that over 200, almost like 250,000 PhD students in all these academic institutions. So India currently ranks third in the world when it comes to research. So we are only behind. China comes first, then comes India, then comes US, and then comes India. So we are just behind China and US when it comes to the research output. But though we are third, but we are still far off from what China and US is. China, for example, every fifth publication in the world today comes out of China. Every sixth publication comes out of US, and every 20th paper rather comes out of India. So therefore we are far behind China and US, but we are still at the third position when it comes to the publications and all that. India is also one of the fastest growing countries in the world at 11%. We are now the fastest growing in terms of research output, the knowledge generation, while the world average is about 4%. So even from that point of view, we are seeing a tremendous growth in the research output from the country. And but we are still not spending enough money. India is one of the lowest spenders when it comes to the research in the country, in the world. As a percentage of GDP, in fact, I have a slide here which I will just flash. Where is that here? As a percentage of GDP, for example, if you see, this is a R&D expenditure as a percentage of GDP. All the different countries, if you see, we are almost at the bottom of the table. I mean, below us are Pakistan, Philippines, Sri Lanka, Venezuela, and everything. And even, smaller countries are spending much more money. The countries which spend the highest money as a percentage of GDP are Israel and South Korea. So these are the two countries which spend the highest amount of money when it comes to in research investments. US is a very large economy, after all the largest economy in the world, but even US, for example, spends close to 2.8%, 2.9% of their GDP on the higher education, on the research kind of a thing. So no wonder these countries which are spending so much of money on research are also the ones which are superpowers in all respects, and India is spending just about 0.6 to 0.7% of GDP on higher education and research. So we are not spending enough, unfortunately, and I hope somebody someday recognizes that and invests more money into academic institutions. So, but despite the low spending, we still are ranked third in the world. The number of papers written, number of research papers written per dollar spent, India ranks number 1. So we are the greatest optimizers when it comes to publishing papers. Give us money, we can write papers, and that nobody can do better than us in the world. So no wonder our PhDs are the most preferred postdocs anywhere in the world, because if you want to write some good papers, hire some Indians. That's what it actually works. But one thing which is also true is, if you take all this money and publish papers and just stay there, do nothing else, it's not going to be sustainable. So at some point governments will ask that question, what has happened out of all the public spending? I mean, we are spending, okay, we are spending less, but whatever we are spending, what have you done with that money? To show us, what has come out of that research. So this is a question that almost every politician is asking, and so that is where a lot of debates are taking place and many things are happening. But I think at some point, with whatever knowledge that we are generating, that knowledge we need to translate it into wealth. While we have become the world's #1 player when it comes to translating funds given to us into knowledge, but we are nowhere on the scene when it comes to translating that knowledge back into wealth. I think that reverse translation is what we need to learn to do. And who will do that? I think it's people like us, people in this room, and we have all been, from good institutions, and at least some of us, in addition to writing good papers, we also need to take that research forward and translate that into wealth. And that is what I personally believe is a responsibility on all of us. Now that I have convinced you that India is doing well in research, I recently was looking in the Scopus and trying to see where India stands in all these advanced technologies, the sensor technology, quantum, nanotechnology, biotechnology. In nano, for example, we are ranked 3rd in the world in terms of research, and in quantum we are ranked 6th in the world, not bad at all. And in sensors we are ranked 5th in the world. So we are, in a way doing well even in these high technologies or the deep technologies kind of a thing. But if you are wondering, we are writing papers, but the quality of these papers is poor, nobody is reading these papers, what's the point in, writing papers when nobody is citing? It's also not true. While we are dealing with this issue of predatory journals, all of that, but a lot of good science also happens in Indian academic institutions, and the recent data from the Ministry of Education shows that 2018 to 20, if you look at, these are all highly cited scientific papers, the country rankings, which countries have written the maximum number of highly cited papers. India ranks 7th in the world right now, even for the citations. We are not only ranked 3rd in terms of the quantum of research happening, but we are ranked 7th in the world when it comes to citations, that we are able to generate, are the top ranked papers kind of a thing. So which is again not bad at all. We have displaced South Korea and Japan to reach the 7th position. So which is something to be proud about, what is happening in the Indian academia kind of a thing. So these are all good, and I showed you this slide. But how do we change anything from only doing research to doing research to also innovate? I mean, doing research to develop more products and all of that. I call the national education policy, which almost everybody must have heard about, is indeed a very good policy. If you read the policy document, the document actually reads very well because it's written by the good people. When it comes to implementation, I have my own doubts, how well we will be able to implement it, but the document reads like what you want to read in a Government of India document. And I call therefore the new education policy as a moral movement for India. What is this moral movement? As I told you, last 10 years we have become much more research oriented. And but when you look at our research, most of our research follows what is happening in the North America and Europe. Somebody starts some research activities there, and we, in an area, and we jump onto that bandwagon, and then we publish. If they have written 10 papers, we will write 20 papers. So that is how most of the research in the country currently happens, that we are following what happens in North America and Europe. Whereas, if you look at the US, right, US is the powerhouse of knowledge, powerhouse of innovation. In the last 20 years, any major company that has made an impact worldwide, all those companies have come out of US alone, whether it is Tesla or Apple or, anything you name, everything has come out of the US alone. And what is that country does that, every innovation seems to come out of that one single country and the whole world follows them. But it was not the case. In 19th century, for example, if you look at, US was not what it used to be, what it is currently. At that time, England and Germany were the pioneers. If you look at the early Nobel Prizes and all of that, most of them used to go to Britishers or the Germans kind of a thing. US was nowhere on the scene. What changed for the US? And at that time, the US colleges were following whatever was happening in the England and Germany. They were like us. In the 19th century, the US universities were like the Indian universities today. And we are still following what happens in those countries. And US in those days was following what used to happen in England and Germany. And basically, much of that research was in natural sciences, theology, classics. So that was the kind of research that was happening. What changed for the US was this act introduced in 1862, which is known as the Morrill Act. What the Morrill Act basically did was, it made, it passed this act which said land grant university model. What the land grant university model is, they said that any universities that are set up as part of this act, the land grant university model, must focus on such branches of learning as are related to agriculture and the mechanic arts. In those days, the two primary activities in the society, were agriculture and the mechanic arts. Industrial age was just beginning to happen there, and therefore the US law said that if you want to create any university, you need to work on areas which have a societal relevance. Basically, what the Morrill Act did was, it said societal relevance needs to be put on top of agenda for any American university established under that under this kind of a law. What is it? So I'm using this, right? This is okay. So we will. So this is what the land grant university model basically did. After that, the US universities, instead of looking up what was happening in Germany or England, they started to connect better with the society, and they started to innovate in areas where there can be a kind of a benefit for the society. And that one single act, in fact, even MIT was established a year after. One of the examples of land grant universities is the Massachusetts Institute of Technology, and there are many universities in the US, almost like 200 universities, which are now considered the centers of excellence, created under this model, started to focus on the societal problems. And that, in my opinion, is what needs to happen in the country. Even in India, while we have such great universities, our connect with the society is oftentimes missing, and that is what we need to be able to establish as part of the new education policy. And the education policy talks about all of those multidisciplinary universities, society connect, exactly the same language that was used in that Morrill Act, as what turned the US universities, into the world-class centers of excellence. So, why say that most of the research that we do today in academia falls under the second category. Solutions, we are developing solutions which are looking for problems, and oftentimes we don't find that problem, so therefore they remain as solutions in our libraries. But what we need to be doing is solution to a problem. I think if you can identify a problem and then work towards doing, providing a solution to the problem, I can tell you the research inherently becomes multidisciplinary. You don't even have to put in any special efforts, to make research multidisciplinary, because all problems, all problem-oriented research is always multidisciplinary in nature. So this is what we need to be doing, and that is what is required in the country. And the role of HEIs, therefore, is not just limited to education and the knowledge generation. I believe the role of education also needs to involve innovation, and innovation is, as I told you, generating value for the research that we do. When did this knowledge become innovation? Knowledge becomes innovation when there is relevance. The relevance is what I call the society connect. If you are working on a problem which has that societal kind of a relevance, of course you will, eventually bring in innovation, because you would have developed a solution to that problem. But not just the relevance for the societal problem, even the delivery model you need to work out. If I have developed a solution, if it remains in my laboratory, it is not of any use for anybody. So how do you take it to the market now? One thing that is definitely happening in many institutions is the startup model. I know CSIR also has a model for the startups and all of that, and that is what that needs to be promoted more and more in academic institutions, because, or the laboratories, because I think the delivery, the startup mode is something which I believe can work very well, in the Indian context. And while the other way you can transfer the technology to society is through industry connect, but then the industry is coming and collaborating with us, I don't think is really happening, despite so many years of struggle with, the academia industry connections. I think nothing much has really changed in the country. But I believe that the startup route is one which can not only connect these startups to industries, but also to the society, and that, in my opinion, is a model that is very relevant for the Indian research, to translate that research into solutions for the society. And I will also try to, explain to you with my own personal examples. I have two successful startups which have been able to do that. It has been a struggle, but but we have been able to develop those solutions now, and many people are currently using them. This is what I think must change. I actually had done a informal survey at my level. I contacted a few hundreds of PhD students, connected with me, and then I started to ask them, where do you find your research problem? How did you find your research problem? I can tell you, depending on which university you go, 70 to 100% of problems actually originate in library. The first thing that we tell the student to do is to go to library and do a literature review, and student goes to library, does a literature review, reads 100 papers, comes back and says, sir, this is not done. Then you start that research, write some more papers. So anything that originates in library oftentimes also ends up in library, and that is how 70 to 100% of our research problems in academia today actually originate, and that is one challenge. But how else you can actually pick up research problems? By observing things in the society. So that is one way one can actually pick up some nice problems. At IIT Delhi, for example, we started rural internship, we started this grassroots innovation programs, we started immersion programs, we started to activate our humanities departments, to suggest problems for engineering departments, and so a lot of things where, the society connect is something we need to strengthen. The industry connect again needs to be strengthened. We, for example, IIT Delhi started this professors of practice positions, the process of practice, and then UGC tried to do something similar, and so therefore, a lot of things to connect again with the industry. And the fourth one is the strategic agency. So the connections with DRDO, connections with ISRO. At IIT Delhi, when I left the institute after my term as director, IIT Delhi, started doing at least 100 faculty members were supported by the DRDO. Almost 300 crore worth projects were sponsored at IIT Delhi through the DRDO route, and so a lot of these problems had close linkages with the DRDO laboratory. So I would like to believe that, or I would like to say that, instead of picking all our problems from library, the society connect, industry and strategic agency connect, if we can strengthen, I think lot of relevance will come to our research, and this is exactly what we tried at IIT Delhi, and it was pretty successful in terms of increasing the research budgets and developing technologies, and many things happened as a result of that. And one another thing which we need to be doing more in India is filing patents. If you want to do innovation, if you want to develop deep technology products, you need to protect your IP very early on, and that is also something which we are not doing enough. For example, in nanotechnology area, I looked up this data for 2019. For example, in 2019, India wrote this many papers, 15,000 papers, ranked third in the world, but how many patents did we file? Just 54 patents. 54 patents for 15,000 research papers that we wrote. In the same year, look at the US. US is the hub for innovation. US wrote about 24,000 papers, right? And how many patents did they file? Something like 5,000 kind of patents there. So meaning for every 5 papers in the US, they file a patent. For every 5 papers, one IP is generated in the US. In India, that number is 300. For every 300 papers, we generate one patent. I think that ratio needs to change. The papers to patents ratio, is something which is a good metric to monitor, and that ratio must increase in the Indian academic institutions. At IIT Delhi, once we realized that, we now brought that ratio to something like 1:15. For every 15 to 18 papers at IIT Delhi, we are now filing one patent. It used to be 1:50, before that, and by putting in place proper mechanisms for filing patents and all that, so now at least every 15 papers results in one patent kind of a thing. So these are some of the things that we need to be able to do. And now coming to my own research, I have another 15-20 minutes for finishing my talk. So my own research, I started my career with the nanoscale devices. But most of my research always involved industries like Infineon, Intel, Applied Materials. These are the 3 industries which funded most of my research. And I did quite a bit of research for Intel, for example. And recently Intel gave me this letter which said that the research that we did collaboratively with Intel has resulted in hundreds of millions of devices, using our technology. So in fact, they said the 10 patents we transferred to Intel have gone into these hundreds of millions of devices which Intel markets every year, and which was very satisfying because, what you developed in the laboratory eventually is in the market and people are using that. Most of these technologies that we developed were for the mobile phones to improve the battery, to conserve the battery power, to do system on chip kind of technologies. So this is where I spent most of my time in terms of doing research. The second area I started to work, starting for the past almost like 20 years, is sensors now. And I work mostly on the microfabricated sensors kind of an area. And the third area is where I combine the nano electromechanical systems with CMOS. So that's also another area that I do. But in this talk, I have picked up sensors as my area of focus. And so I will skip some of this since we don't have much time. But all of these falls under the nanotechnology domain. Right, and India is launching a major mission on nano electronics. We want to become the world's hub for the nano electronics manufacturing. And so while we would like to have more and more foundries to come and set up shop in India, start manufacturing chips, I think the way the academia can contribute to some of this research is by doing more of system oriented research. We are not working on enough system oriented research. Most of our work still remains at the device level, at the process level, but we don't take it all the way to developing a complete system. So if you want to start a company, if you want to do innovation, if you want to translate research into a product, I think the system focus is very important for academic institutions and research laboratories. So that is what we need to be doing more and more. And so this is where I have some views on that. And I will in the sensors area again, India is doing very well. This fall here is because of COVID. But India, as I told you, ranks 5th in the world when it comes to sensors research. And I believe sensors research has tremendous potential. In fact, all these surveys that are available online show that the sensors market will be about $1 trillion. The per year market for sensors will be $1 trillion by 2035. And India has a potential to capture some of this market, and all of this research happens as part of the Internet of Things. I mean, you have not only sensors, but you have the entire system with the electronics embedded around them is what we need to be working on, while the entire semiconductor market today is about $600 billion, while sensors market alone will be $1 trillion. So to me, if India needs to capture any of the world markets for the semiconductor technologies, sensors is our opportunity. And since there is already a lot of research happening in academia on sensors, I think if we can all work in a very focused fashion on sensors, in developing these IoT kind of systems around sensors, I think India can capture a lot of this market for us. And when you want to develop a complete IoT system, you need a multidisciplinary kind of a team, because IoT systems involve electronics, they involve software, they of course involve the sensors, they involve the power source, they involve the network connectivity. So when you put all of this together, that is when you call it the IoT, and that is where the markets actually lie. Otherwise, just developing a sensor without all these associated sort of components will not really fetch us those kind of markets. And a lot of interesting things are happening on that, and good kind of research is also happening. And I started my sensors research with an aim to develop a cardiac diagnostic system. At IIT Bombay, some of us came together. We said we will develop a chip which can detect heart attacks. That was our very first problem. We really did not succeed in that. We developed a prototype, and which was working very well in the laboratory, and then we wanted to take it to the market by tying up with hospitals, doing hospital trials. But once we started to tie up with hospitals, it was something which became totally out of control, unmanageable. But otherwise, this was a problem that we took up very first, the cardiac diagnostic system, to detect some of these markers like troponin, CKMB, myoglobin. And we had a system-oriented approach. We said you start with the blood, you develop the filters, you have microchannels, you have sensor array, this entire disposable chip and a tabletop electronics. So we had at least 7 departments at IIT Delhi coming together, forming a team, and we received funding from the National Program on Smart Materials and subsequently from the NPMAS, which was funded by DRDO. And we worked, very hard in getting this technology out into the market. We developed this cantilever platform as a part of that research. When you have these piezo-resistive cantilevers, you coat them with antibodies. When these antibodies bind to the cardiac proteins, the reaction is what we detect as a stress. The stress causes a strain. The strain changes the piezo-resistance value. So any binding on the surface of the cantilever is what you can detect as a electrical kind of a signal, because these are all piezo-resistive cantilevers. So that's what we developed, and we developed lots of technologies, and a lot of good work went into that. We wrote many papers, we filed many patents, we even developed a complete prototype for this. For example, the prototype you see electronics, and this is how the prototype actually looks, and this prototype works in the lab. With a sample of blood, you can actually detect the cardiac markers. But then the hospital trials, like I told you, because the cardiac marker concentrations can vary from state to state, and you have to do huge number of trials if you ever want to make this technology work in the field, and that required lot of funding. And after developing the prototypes, we were not able to secure that kind of a funding, and then we started to look at other things. But we actually started this company NanoSniff Technologies to commercialize this product. So we transferred this technology to NanoSniff, and then NanoSniff struggled hard. NanoSniff developed more prototypes, but then they also got stuck at some point. I will tell you, it's not completely shelved, but it's rather on a back burner kind of a thing right now. And once we started facing that problem, and around that time, after about 4 years of starting the cardiac project, we received funding from Principal Scientific Advisor's office to develop an explosive detector system. The technology was exactly similar. The technology was to use the same cantilevers, but instead of antibodies, you put the receptors, and these receptors will bind to the vapors of explosive. So the principle of measurement was exactly similar. So we started working on this alongside the cardiac project. And so here again we made considerable progress. So we had these different molecules synthesized for us by the chemists. We started coating them on the cantilevers, do the test, and we subsequently developed an electronic nose platform, and then we actually transferred this technology to the SCL, Semiconductor Complex Limited, and we did many tests with them. But the sensitivity here, the false positive rate, was only about 80%. In 20% of cases, it was wrongly recognizing other things as explosives. So that is the false positive rate. So we went up to 80%, but then the security agencies said, with 20% false positives, it's very difficult to use this technology at an airport and other kinds of places. And then we started to look at other ways to do that. And so one of the very interesting ideas we got around that time was a physics-based approach. Until now, it was more of a chemistry-based approach, where you make these cantilevers, coat them with receptors, the receptors binding to explosives. So that was an approach that we were taking. But we said, so we then, one fine day, we got this idea, let's use a physics-based approach. What is a physics-based approach? The property of an explosive is to explode. So we said, can we actually gather some of these explosive molecules from the vapor, right, or from the swipe? When somebody has carried explosives, you take a swipe, collect some particles of this explosive, 10 nanograms, let us say, you sample 10 nanograms either through a swipe or through the vapor, and you actually collect them on a sensor and explode them. When 10 nanograms of explosives explode, how do they explode? To explode, you want to give them a thermal shock. Otherwise, they are very stable kind of materials. So we said we will build a tiny micro heater, and these micro heaters will have the explosives gathered on the surface. When you now ramp the temperature from room temperature to, let's say, something like 350 degrees centigrade, a thermal shock in a matter of milliseconds, the explosives will go through what you call deflagration, a rapid kind of a combustion. So when they deflagrate, because these are all exothermic reactions releasing energy, energy, they change the temperature of the ambient in a very slight fashion. So we said along with the micro heater, you have a tiny temperature sensor which is now monitoring the temperature changes because of that explosion. So that was the whole idea. So because only explosives will explode, you are essentially very selective when it comes to detecting explosives. So you explode these 10 nanograms of explosive, the exothermic reaction which results in the temperature change is what you are monitoring, and doing the thermal signature of the thermal analysis of the resultant heat, and that is how we actually started to build the product around it. And we started developing these micro heaters with temperature sensors at IIT Bombay. This entire technology we used academic fabs. Then we started using the IASC fabs for this, but entirely made in the IIT and IASC. And then we were able to actually develop this technology. So I have a small video, which actually highlights this, and I hope, let me just do this. How do I play this? Oh, no. Is there a way to play this video? Can you see how to play this video? Is this connected to the internet? Oh, it is not connected to the internet. Is there a way you can connect it to the internet? Oh, it's a YouTube video. So.
No, this is not connected.
So I will use my mobile phone.
Internet connection. This one.
Yeah. Oh, this is.
इसका साउंड
Sound muted here? I hope not.
Technologies, an IIT Delhi incubated company, and NanoSniff, an IIT Bombay incubated company, jointly manufacture and launch NanoSniffer, an advanced and affordable explosive trace detector. Screening visitors and passengers for explosives at various public or crowded spots have become the norm due to the increase in the terrorist activities around the globe. Every luggage and person passing through the security checkpoint is tested by the security officer to check whether they have traces of explosives on their surface, skin or hair. Nano Sniffer proudly claims to be the first explosive trace detector in the world using micro-sensor technology. The micro-sensor of Nano Sniffer is made using micro-electromechanical system, MEMS technology in semiconductor fab. The sensor uses fabrication techniques such as lithography, etching, deposition, spin coating, and finally released to the microsensor. The core technology is protected by patents in the US and Europe. All of our actions leave trace behind, which is then screened by the security personnel. The security has to concentrate at the sampling areas that are likely to be touched by hands. In the case of a bag, this will include handle, buckle, and zipper. Post-sampling, the swipe is inserted into the system where micro heater subjects the particles into rapid heating. In case of explosives, this trigger exothermic reactions which are picked up by the integrated temperature sensor of the micro heater, thereby landing each compound in its own thermal. Algorithms use these signatures to distinguish between explosives and non-explosives. Further analysis of the algorithms help in categorization into the appropriate class of explosives. The follow are few Nano Sniffer features. It is the first microsensor-based ETD. It detects and identifies explosives in less than 10 seconds. Identifies and categorizes explosives into different classes. Can detect ng quantities of explosives traces. It detects all classes of military, conventional and homemade explosives. It is portable and affordable. It gives visible and audible alerts with sunlight readable color display. Nano Sniffer explosives trace detection technology can be deployed at airports, railway stations, ports, malls, metro stations, corporate parks, hotels, and tourist spots. The goal is to intercept and prevent access of explosives trafficking. Nano Sniffer is 100% made in India product.
So this technology, as you can see, is this is a totally disruptive technology in this space, and there is no equivalent product anywhere in the world. And anywhere where there is a tendering process, we win all the tenders, hands down, because nobody can compete with us on the price or on the specs also, because it doesn't differentiate between any kind of an explosive. Anything that explodes, it detects. So there is no chemistry there. It's all physics, and physics always works. So this is, we are in the National Physical Laboratory. So this is a sort of a disruptive sort of a technology, and now all airports in India are buying this. In fact, as I speak, Delhi airport has placed order for 20 systems, and there are 7 airports which have been buying that, and at least we just launched it last year, and 50 systems are sold. Now the inquiries are exponentially growing even from all over the world, and I think this should be a disruptive technology in the market. And now in my group we are looking at miniaturizing that, converting it into an IoT node. And that's what we are now in the process of doing. But when you talk about IoT, when you want to develop these sensor networks, the power is important. So in these cases now, this explosive detector, we are trying to generate power from the vibrations in the buses and trains to use piezoelectrics, and use the piezoelectrics to actually drive the explosive sensor. That's the whole idea, and that is all how the research is progressing right now. But after the success of this explosive detector, and it's all available on GEM now, anybody can buy that. And now I started working on agricultural sensors for the last 5 years. After I moved to IIT Delhi in 2016, I started a major activity between IIT Delhi and IIT Bombay. And here our goal again is a product system oriented approach. So in this particular case, we want to develop sensors which are needed for the soil health card. So these soil health cards have been given to farmers in the country. So we looked at all the micro and macro nutrients that are required for soil measurement in the soil that are to be measured, and we started working on developing low cost sensors for this application. So we wrote a project to Department of Science and Technology with basically the goal again is a system approach where 4 prototypes: volatile tracking, pathogen detection, moisture, pH and salinity, micro and macronutrients. So between IIT Delhi and IIT Bombay, we have worked for almost like 5 years now, and we started our first company. My second company, for example, was on nano soil sense. So this is the company I incubated in 2018, mid 2018, and this company now last year launched the NutriSense. And this NutriSense, as you can see, it can measure electrical conductivity, it can measure the pH of the soil, it can do nitrate, phosphate and potassium. So it can do NPK now, and it's again the world's the smartest NutriSense. In fact, you can download the app on Google Store for this, and this again has picked up a lot of traction. And this is a sort of a disruptive it's based on electrochemistry. We tried many other approaches, but nothing really worked to our satisfaction. So this electrochemistry based NutriSense is now in the market, and it's again selling very well. And it's so simple to use that we are now training the villagers themselves so that they can provide the service and earn some livelihood. And so this is again, and here we of course sell it directly to farmers, but we have also tied up with big companies which are in the agriculture space. So we have a complete soil sense station from the Soil Sense company, this startup, and the portable soil moisture sensors and multiple an array of a suite of technologies we have for agriculture right now. And we have tested it in the field very extensively. IARI was our partner for many of these testings, and we are now tied up with all these companies. In fact, many of them, we are the technology providers now. The startup is the technology provider. And so this is how, once you keep system as a focus, you can start developing prototypes, and through the startup, you can actually take it to the market. At least this model for me worked very well, and most of these are now in the market. NanoSniff was my first company. They survived by commercializing the cantilever platform that we developed, and the explosive detector became their mainstay. That is what is getting them now revenues. And the cardiac sensors thing which we transferred to them is what they want to take up, because that requires, anything healthcare needs a major trials, and that requires money. And the cardiac thing, though they have the prototypes, but they haven't done the hospital tests. But this is the money that they want to earn from explosive detectors, invest it in the cardiac thing. So hopefully that will also see the light of the day one day. And the second company that we have is the Soil Sense, and this company is doing very well now, and they are able to commercialize many of the agricultural technology. So I think in the country now we need to take this system-oriented approach if we want to innovate. Whether it is in the security space or in the agriculture space or in the healthcare kind of a space. And I think this sort of an approach even works for the institutions. At IIT Delhi, we also took this kind of an approach, of bringing unlike minds together, develop ideas and then translate them through startups. And we launched initiatives at IIT Delhi to encourage faculty to start companies. For example, this FIRE initiative, Faculty Innovation and Research Driven Entrepreneurship, where any faculty member at IIT Delhi who says, I want to start a company, we give them 50 lakh rupees as a grant. These are all equity investments, and the faculty member can start a company, can take sabbatical to do startups. Until that time, sabbaticals were only meant to go abroad, teach and earn some money. But now we started giving sabbaticals to faculty who want to start companies, and then also pay them some grant amount as a equity investment. So this has made a huge difference, and I think some of these, I believe, are what we need to be doing. And even during the COVID time, we took a similar kind of an approach, focus on COVID solutions and use startups as a way to take these technologies to the market. And we filed 153 patents during the peak of COVID, and 18 patents on COVID technologies, whether it is the low-cost RT-PCR kit or the rapid antigen kit at 50 rupees, all of them came out of IIT Delhi research. And I think I believe this is a model that we need to follow in academic institutions. Instead of waiting for some big industry to come and take our technology, develop the technologies, encourage your scientists and faculty to start companies, and then take these technologies to the market. And I think this is my last slide. So India is opportunities, and we need to do local R&D for product development and suiting the Indian requirements. And using the startup kind of a process, I believe a lot of new technologies can come into market from India. I will stop here. Thank you very much.
Thank you, sir. I request the director, sir, to kindly come up on the dais, and also Dr. Ritu Srivastava to please come up on the dais. Thank you, sir, for bringing forth the importance of the innovation-driven research and also telling us about the opportunities and the solutions to several scientific problems and the barriers, and how incorporation of relevance and delivery to knowledge can lead to innovation. Thank you for also encouraging us to raise the patent to paper ratio. And personally, as I also work and I'm interested in the field of sensors, it was so informative and encouraging and very true that we are restricted only to device formation and not the system as a whole. So thank you for giving such valuable insights to us. And we are really humbled and honored by your presence, sir. And now it is time to felicitate our keynote speaker, and I segment, and the results are on their way, so you can keep build up that curiosity. And I know that you might be having goosebumps to know the results. So just for the information, that there were 385 students who participated in the quiz competition, and they were given just half an hour to answer 150 questions, science questions. So a huge round of applause to our dear students for answering these questions within such a small time frame. So it is really commendable, and all of you all are winners here. But just as we need to select, so we are going to select top 10 amongst 385 students. And these 385 students have been from 5 different KVs from all over Delhi. I also thank their teachers and their coordinators who have brought them to this occasion. Thank you to the coordinators. So can we have a clap for the coordinators and the teachers of these KVs? Okay. Just sharing a little information, just as a director, sir, has mentioned in the address, that this would be a 5-day program starting today with the inaugural, and then after this, in this league, there will be a sequence of other different programs, and the first one, that is tomorrow, is titled as the Startup MSME Industry Meet. And this event is actually to showcase the NPL's various services that are extended to industries. And on 19th April, it would be the Metrology Conclave, and where there would be the release of a pocket booklet on advances in metrology at CSIR-NPL. And on 20th, there would be an R&D conclave and women in STEM. So it is planned with the eminent scientists of the NPL family who have worked here, who have served in NPL. So we will be very fortunate to have them again back in NPL and have an interaction with them. And it will also focus on women's empowerment during these said events. On 21st April, that will be the closing of this event, we would have the skill conclave. And the primary focus of this conclave is to educate the common people about the local goals that are in identifying the counterfeiting that is done. So it would be a very skilled manpower demand in the country and by different industries. So I encourage you all, because this would be a one-on-one scientist to student and scientist to a common man interaction. So I encourage you all to please be present. And for more details, you can also log in to the CSIR-NPL portal and visit. And also, this event is live streamed. So I request you all that who all could not attend can also attend it through the live stream platform. So we have the results, and I request our honorable chief guest for this event to kindly come forward. So, to dispel your apprehensions, I declare the awards for this quiz competition. Pragyan Gaur from DBRA SOSE Civil Lines won a prize in this quiz competition. Pragyan Gaur, if you could come on the stage. Yamesh Sharma, KVS Sector 8, Rohini. Shaheen Chaturvedi, KV Pitampura. Harshit Kumar, KV Sector 8, Rohini. Sundaram Singh, KV Rohini, Sector 8. So keep on the heartbeats raising as I keep announcing. Aditya Ranjan, KV Pitampura. Sundaram Singh, KV Rohini, Sector 8, please come forward. Mansi, KV Sector 8, Rohini. Pooja, KV Sector 8, Rohini. Aditya Jain from Bhatnagar International School. And Jyoti Purti from KV PUSPH Vihar, Pushpa Vihar. Many, many congratulations to these top 10 students. Everybody who participated is a winner in itself. So do not be undermotivated, but be encouraged to do much more well in the times to come. It was indeed a very thrilling experience because the competition was done in the morning and the results were prepared just now. All the scrutiny and everything were being done during this entire event. So a very, very congratulations to the organizing team as well for providing the results in a very short span of time. So please put your hands together for the organizing team of the quiz competition for providing us the results and scrutinizing them to their best and giving us the certificates and the prizes to these dear students. Thank you to the organizing team for conducting, for invigilating, and for providing the results for this quiz competition. The excitement among the students is really contagious because they all were so excited to hear the results. And congratulations to the students who have won. It is indeed a moment of great honor for the students to having received these certificates from Professor V. Ram Gopal Rao and from the Director CSIR-NPL. For any kind of query related to quiz competition, you can connect with the coordinators associated with it. Thank you to our esteemed dignitaries for doing the honors. For any kind of confusion, I request the teachers to kindly coordinate with the quiz competition organizers. I once again extend a heartfelt thanks to our keynote speaker for his valuable insights, and I thank you all for being a great audience. And as we have come towards the end of the first segment of today's event, it's been a very wonderful and insightful experience, and we hope that you had a great learning. After the tea break, we have the much anticipated and the keenly awaited segment where we will have our Honorable Minister, Honorable Jitendra Singh Ji, with the other distinguished guests for the grand inaugural and launch event of CSIR HRDG student-centric initiatives. So I request you all to kindly be seated in the auditorium before 11:45. And the students, I request you all to remain seated in the auditorium. The rest of you all can move out for the high tea, and please come back within the time so that we can start the program by 12. I thank you all, and we will resume the session after the high tea. Our esteemed dignitaries, please escort them towards the VIP lounge.
I follow you on Twitter. No IT
maintain the decorum of the event. And the standing ovation is in honor of our Honorable Minister. The doors have opened. Our dignitaries are entering the premises, and I request you all, as soon as they enter, please give a huge round of applause. Our Honorable Minister of State, Independent Charge, Ministries of Science and Technology and Earth Sciences, and Vice President CSIR, Honorable Dr. Jitendra Singh Ji has arrived amongst us to grace this occasion. Accompanied with him is Professor V. Ram Gopal Rao. We also have Dr. Narahari Sastry, Director CSIR NEAST and Chairman Jigyasa Task Force, and Dr. Geeta Vani Raisam, Head CSIR HRDG. Accompanying them, we have Professor Venugopal Achanta, Director CSIR-NPL. I request our dignitaries to kindly come up on the dais. Let us keep up the energy and applaud our esteemed dignitaries. Kindly be seated. Every great event starts with a small idea, a spark of creativity, and a commitment to make it happen. It is indeed a beautiful day as we commence today the inaugural or one of the most remarkable events in the annals of history of CSIR-NPL. I, Dr. Sharon Jyotika Paul, on behalf of the entire CSIR-NPL fraternity, extend a warm welcome to one and all on this auspicious occasion of 1 week, 1 lab campaign. It is, as we say, first of its kind event where the CSIR labs are provided this opportunity to showcase their diverse legacy, exclusive innovations, and technological breakthroughs to the common people of India. In the league of this unique campaign called 1 Week, 1 Lab, CSIR-NPL is organizing the program from 17th to 21st of April with the aim to create awareness about the available technology and services present in NPL among potential stakeholders, to provide solution to societal problems, to sensitize the masses about importance of precise measurements, and to develop the scientific temperament among masses, especially among students who are the future of the country. Today, we will also witness the pivotal event, the launch of CSIR HRDG CSIR student-centric initiatives, CSIR Yuva Portal, Jigyasa Mobile App, Astro Lab for Divyangjan. These initiatives will strengthen the academic and personal growth of students and also empower them to take ownership of their education and become leaders in their fields. To grace this occasion, we have our esteemed dignitaries on the dais. We are honored to witness the advent of this commendable program. I extend a warm welcome to them and the distinguished guests, our revered scientists, our dear teachers, media partners, and of course, our lovely students and research scholars. Before we begin today's program, we would like to welcome our esteemed dignitaries with a token of delight and request. I request our dear students to kindly welcome Honorable Dr. Jitendra Singh Ji for being a significant part of this historic event. Ms. Lalita, please come forward to welcome our Honorable Minister. Your presence here today is a testament to the significance of this occasion, and we are so grateful to have you to grace it. Thank you so much. We extend a hearty welcome to respected Professor V. Ram Gopal Raoji with a token of gratitude. I request Mr. Ankur to kindly come up. We are honored and humbled by your presence today. Thank you so much. We welcome Dr. Narahari Sastry on this auspicious occasion. I request Ms. Ria to kindly come forward. Thank you, sir, for your benevolent contribution to this event. We also extend a warm welcome to Dr. Geeta Vani Raisam. I request the Chinmay to kindly come forward. Thank you, ma'am, for gracing this occasion. We are honored to have such dynamic personalities amongst us. I now humbly request our Director, CSIR-NPL, Professor Venugopala Chanta, to kindly accord a ceremonial welcome to our venerated guest and this august gathering.
Thank you. Yes. Honorable Minister Dr. Jitendra Singh Ji, Professor Ram Gopal Rao, Dr. Narar Shastri, and Dr. Geeta Vani, and all my distinguished colleagues from headquarters, fellow directors. I see the new PME head, also RAB director also here. Sorry, I'm still. So, and my ex-colleagues, former scientists from NPL, my present colleagues from NPL, students who came from many of the schools across Delhi NCR. So to make this occasion a special one. So I would like to welcome you all on behalf of NPL family and CSR family to this dual event. One is, as we know, is the 1 week, 1 lab event, inauguration of it. So this is a brainchild of our honorable minister. So that this idea is each of the CSR labs does a lot of work, and each of them specializes in very unique and specific areas. So his idea is, why not take this message, what we do in each of the CSR labs to the general public, so that they are aware of what is the work going on, and also take this opportunity to interact with the stakeholders, for example, industry partners or other partners, which I'll be mentioning shortly. So each lab has their own unique ways which we interact with the society. So this is an opportunity where we take 1 week and completely dedicate it to send the word and bridge the gaps whichever are there with our stakeholders. So that was the idea behind this 1 week, 1 lab, and it's going well with many of our sister laboratories conducting these activities across the country. Right. So to come up to this stage, we have support of our media partners, without whom we wouldn't have reached many of you. So I would like to thank, on behalf of CSR family, our heartfelt gratitude for the coverage which you are giving to this event. Right. So before starting the event, so I thought I'll just briefly say what NPL is. I had given this in the morning session, a little introduction about NPL. So when we talk about NPL, like, so we all talk about, I mean, in the context of Big Bang theory, right, for the universe, how universe is formed. So there was a Big Bang, and then the universe slowly evolved over time. So for NPL, many of people, how NPL is recognized is with the time, the Indian standard time. So there are these 6 beeps which used to come on one of our event partners, All India Radio here today. So they used to have these 6 beeps. 6 beeps are of 0.1 second each. So the 6 beeps corresponds to 1 second, 100 millisecond each beep. So that's how the time used to be disseminated across the country way back in 1959. So this was started 4th February 1959, and this was the first time in South Southeast Asian countries, the first country to disseminate time. And this evolved. In 1974, we got our first atomic clocks. Then in 1979 onwards, we started using the satellite technology to disseminate time with much higher precision. And this is just one activity which is well known to people. There is a lot more which goes on just in the area of metrology. Even for this time dissemination, there are ongoing projects. We plan for the future, how we can better the accuracy of time which we give, and different ways so that India becomes self-reliant from safety security point of view. Okay. So this is one thing. The second area which NPL is well known is for advanced materials. For example, one of the offshoots is the Central Electronics Laboratory, which was established in 1974. Sorry. So it's an offshoot of NPL. So then I also showed, briefly mentioned about this TV, black and white as well as color TV phosphors which were made, crystal growth and XRD equipment which was made at NPL way back in 60s, 70s and 80s. There are superconducting magnets which were made. There is materials for aerospace, semiconductors for solar cells, and currently we are working on futuristic quantum materials and quantum sensors and their applications. The third area is environmental sciences. So the NPL team participated in almost every single Antarctica expeditions. We set up the SODAR there, designing and developing spectrometers for observing the Antarctica environmental conditions. We do pollution monitoring. What we are doing currently includes, for example, across the Delhi NCR region, what are the domestic fuel consumptions, different types of fuels which are used, and what are the pollutants, what are the emissions which come out of it, so that this can be used for policy making. So we also model the pollution, how it transmits across the lower Himalayan regions. So this is ongoing work, so we keep on extending these things to meet the current demands and future demands of the country. The fourth activity which we are very passionate about is skill development. This is interaction with school days, schools, various schools. We have these open days. Last Thursday of every month is a open day. Anybody can come in with prior registration, or even walk-ins are possible. We organize this PG diploma course in PMQC, which we call this precision measurement and quality control. So this is again a very successful course. So we have about 180 schools whom, across Delhi NCR region whom we collaborate with. We actively involve ourselves with the various ministries and stakeholders, including Bureau of Indian Standards, Quality Council of India, Legal Metrology, and industry, covering various aspects. We talk to defense labs, we collaborate with them, ISRO, the space organization. So we do have active collaborations to take our work or identify the problems which are need to be solved to wherever extent like we have the internal expertise with. So this 1 week program under the guidance of our Honorable Minister is to showcase NPL and to connect with all stakeholders. So I welcome you all to this 1 week program, which will be inaugurated by our Honorable Minister now. And we also have our event, HRDG event, inauguration of student-centric initiatives of CSIR HRDG. And we look forward to having you all during this event and the next 5 days. Thank you all.
Thank you, sir, for doing the honors and for precisely highlighting the role of NPL in providing measurement standards to the country and the innovations that NPL is developing with the futuristic perspective. Thank you, sir. Our beloved Dr. N. Kalaiselvi, Director General CSIR and Secretary DSIR, who was supposed to be here to grace this occasion as a guest of honor, couldn't make it today because of some health constraints. She is truly an indescribable asset and strong pillar to NPL, and we hope and our sincere prayers for her speedy recovery. I now request Professor V. Ram Gopal Rao to kindly come up and enlighten the gathering with a few words.
Good afternoon, all of you. Dr. Jitendra Singh, Honorable Minister for Science and Technology and Vice President CSIR, and Professor Venugopal Achanta and other directors present here on the dais, off the dais, students, scientists and everyone. Very happy to be here. This is indeed a very great event. 1 week, one lab. I understand Honorable Minister himself thought about this initiative. And CSIR is a very large system, and it's very often for outsiders to know the magnitude of this entire operations and the number of laboratories and nature of activities. I think it's good to focus every week on one lab and showcase it to the other society kind of stakeholders. And I'm sure this will bring in a lot of visibility to the activities that are happening in the CSIR system. I have always said that the problem with our institutions is they have become too homogeneous. It's always about professors talking to professors, scientists talking to scientists. I think that is hampering our innovation capabilities. Ideas happen. The idea factory kind of an approach is when unlike minds come together. Unlike minds, unlike in terms of attitudes, unlike in terms of disciplines, unlike in terms of cultures. I think that is what we need to do. I think we need to connect with stakeholders, and we need to bring these unlike minds together, make them interact with each other, develop ideas. And once you have an idea, and of course you can pursue that as a research, you can generate further more ideas, use startups, use industries to translate that research. I think that has to be the path forward. And from these homogeneous kind of cultures, connecting with different stakeholders need to become our mainstay in all these academic institutions. Now, I wish all the best for this event. Today is the first day, and I have already given my talk. So I'm very happy to see the response, and I'm very happy to interact with all of you. Thank you very much. Thanks a lot.
Thank you, sir, for your words of encouragement and appreciation towards this event. Jigyasa program, a scientist-student connect program, has come a long way since its establishment. It is one of the important outreach activities of CSIR targeting school children. Now, I humbly request Dr. Narahari Sastry, Director, CSIR NEAST, and Chairman Jigyasa Task Force to deliver the vision and future roadmap of Jigyasa.
Thank you very much and good afternoon. Honorable Minister for State, Independent Charge, Ministry of Science and Technology and Earth Sciences, and also Vice President of our Council, Professor Ram Gopal Rao, Professor Venugopal, Professor Ranjana Srivastava, and our JS and many other dignitaries who are there. It's a pleasure for us to be here to see a simple idea that our Honorable Minister has floated on 26 September 2022 to become a reality. When scientists discover things and make a difference, many times scientists themselves will forget, and most of the time when it does not reach the society, the full-fledged use of that is not very well spread. Awareness is very important. So this 1 week, 1 lab program, which is a very, very good success. I have participated in 2-3 labs, and we had our own laboratory doing this. Many times we bring awareness to others, and we also bring internal awareness. What are our internal strengths, and what are the problems that we have done, what we have to do, what we can do. In all these directions, this particular 1 week of Manthan, while we have an intention to bring awareness, it will also bring the new opportunities that we can think about. And today my role is to talk about the Jigyasa program, the Scientist-Student Connect. Again, this is an idea which came from the very top, and it started in 2017, although these programs were there for 40 years in some laboratories. But in 2017, with the Kendriya Vidyalaya Sanghatan, this has taken a firm shape, and from 2017 till now, more than 1,500 programs were conducted, and close to 5 lakh students around and 5,000 teachers have been participating in this particular program. And we have several projects which have come in this way. As one of the very interesting thing is this Indian Sign Language, where people who have some challenges will also focus on their strengths. And today, on this occasion, we are going to launch the CSIR Yuva portal, the Jigyasa mobile app, as well as the Astral app for the Divyangjan. So, we are now trying to look at what are the ways in which we can engage the young children in doing science. As Dr. Ramgopal Rao has mentioned about, we are being more too homogeneous or too monotonic. If you want to have a disruptive ideas and in our thinking, we have to catch people at the right age. And according to most people, people will have their mind at its best between 17 years to 20 years or 15 years to 20 years. And at that particular point of time, if you engage with them, the interaction from scientists and students, probably the learning process are both ways. I strongly feel that whenever I interact with young students, we also learn quite a bit things. And then people who have some challenging issues like our Divyangan, they also have lots of things for us to teach, provided we are willing to learn. And we are also having several programs in this Jigyasa initiative. Like, one of the advantages that CSIR has is it has its presence in the length and breadth of the country, 37 labs distributed, and we have a legacy of more than 80 years. And we wanted to use this to convert the knowledge that is there in all the 14, 15 vernacular languages. This particular idea is going on, and we have signed MOU with the Royal Society of Chemistry and Chief Development Office of the Bulandshahr and Karnataka Science and Technology Academy, and we are also very soon going to sign MOUs with the S&T councils with the different states, Rajasthan, Gujarat, Telangana, Assam, many other places we are talking, so that the knowledge that was created will be distributed in different vernacular languages. And also, we have this Jigyasa virtual lab platform with more than 170 contents with the help of the IIT Bombay. This has emerged as one of the most important aspect of our Jigyasa program, and we are very sure that COVID has taught us many things, that if we want to really access to the quality material, education material, these virtual labs are playing a very important role, and IIT Bombay and many CSIR laboratories are involved in creating the course content, and this course content will be available in different languages. And we are also having the mobile bus in collaboration with the NSCM, and this mobile vans will go to different places in the villages, and then we will try to see that CSIR work along with the different education institutes. And we all feel that in the last few years, we are learning to work cutting across the different line ministries and working very closely with the other education institutes, and this will be very helpful. Jigyasa labs are also actively working on AI-based tools and software to monitor and map the skills and competency of the school children. This is actually one of the points that was raised by the Honorable Prime Minister during our society meeting, and we are taking it very seriously, and then we are working towards that. And another thing is, the Niti Aayog has created the Atal Tinkering Labs. There are about 219 Atal Tinkering Labs, and many of the CSIR institutes are adopting them, and they are working very closely. For example, in Jorhat, we have about 20 Atal Tinkering Labs, and we go to each of those schools and then try to handhold them and then see that how they can really become innovative and making some differences in the practical sense, because lots of structural strengthening is happening in this 295 and there is a plan to expand it further. So with this, we have every reason to be happy with very nice leadership and then camaraderie that is there across the CSIR to work in the Jigyasa program. And definitely, if you are able to work and excite some of the children, when we are able to catch them young and provide a good atmosphere, definitely country will progress in a good fashion. Thank you very much. Jai Hind.
Thank you, sir, for sharing the importance of creating awareness. We believe that this initiative of Jigyasa program will surely empower our young children to make a revolutionary difference in the world. Right behind me is a volunteer who is miming for the Divyangjan students. CSIR HRDG has been contributing significantly to the development and nurturing of science and technology manpower of the country through its fellowship programs. One such program is the Direct Senior Research Fellowship and Research Associateship under Extramural Research Scheme. CSIR HRDG, under the leadership of Dr. Geeta Vani Rayasam, head CSIR HRDG, has been steering the Extramural Research Fellowships and also the Jigyasa program as well. 3 major game-changing initiatives have been developed. Now, I humbly request Dr. Geeta Vani Rayasam to share the overview of CSIR HRDG's student-centric initiatives, CSIR Yuva Portal, Jigyasa Mobile App, Astro Lab for Divyangjan students.
Good afternoon, everyone. And firstly, Honorable Minister Dr. Jitendra Singh Ji, Dr. Venugopal, Dr. Ram Gopal Rao, Dr. Shastri, and all the dignitaries of the dais, and all colleagues of NPL and students, and all Jigyasa nodals who have joined online. I think it's a great, I'm very happy here to be on behalf of HRDG to talk about the initiatives which will be launched by the Honorable Minister in just few minutes. And firstly, I think hearty congratulations to NPL on the 1 week, 1 lab program. And I really we piggybacked on NPL for this event. And so my sincere thanks to Dr. Achanta Venugopal. So actually, as we just heard, CSIR is not only known for its technologies, which is what CSIR's mandate is, but we are also known for nurturing human resources. In fact, it's in the mandate of CSIR. The founders of CSIR in 1942 talked about that CSIR should play a very vital role in nurturing the human resources. And when we talk of Amrit Kal, it is these students who will be there in 25 years. We may not be there, but they are the future scientists of the country. And I think it's very important we engage with them, either through the Jigyasa program or the 1 week, 1 lab program. And I'm very happy to see a large number of students. And as you know, Human Resource Development Group is the only one which caters to the extramural or non-CSIR phase of entire CSIR activities. So today I'll just take you through the 3 initiatives what Honorable Minister is going to launch. So first is the CSIR Yuva portal. Actually, the Yuva is for Yuva Vaigyanik Anveshan portal. So this is for the direct SRF. As most of you know, CSIR has this national level competitive exam called CSIR UGC NET, based on which the students are given fellowship to carry out research in various labs across the country. But what about those people who don't clear the exam, for example? Are they not good scientists or good researchers? So there are many who work in projects in various labs and do excellent work and also come up with publications. So this direct SRF scheme is for those students who actually go on to do research and come up with publications, and to give them incentive to go to the next level of fellowship, which is a senior research fellowship. So this platform is actually actually for those research scholars. And we all talk about brain drain, and more after PhD, most students go abroad, as you know, for postdoctoral research. But there are also schemes within the country, and Research Associate is a fellowship for those students who want to, or those PhD scholars who want to continue research. And so this is a Research Associate scheme, which is also monitored by CSIR HRDG for the entire country. And I'm very happy that we'll be launching this portal shortly, and the advertisement, which has been on hold because of COVID and other reasons, will be released today, and the portal will be open at midnight, 12 o'clock, and anybody from the country can apply for this fellowship. And so why this portal? And as I said, earlier it used to be done in an offline mode, and because of COVID, offline mode was very difficult, and I think in line with the Government of India's initiatives and towards digitization, it's high time we move on. And so in partnership with CSIR-NPL, we have developed this portal, and this is going to reduce the resources and time and manpower, a lot of time and no extra screening, and usually we get 8,000 to 10,000 applications, and this is going to really cut down a lot of time. So this is one such new initiative at HRDG. Now, Dr. Shastri really highlighted about the Jigyasa, and we are very fortunate that our Honorable Minister has been very encouraging for this Jigyasa, and as I can show here, in fact, our first virtual lab was launched by the Honorable Minister himself in 22nd November 2021, and we also signed an MOU with National Council of Science Museums in presence of two ministers, Shri Kishan Reddy ji and Dr. Jitendra Singh. And now, as a follow-up of this, we are having a museum being set up in Hyderabad, and a science museum, and we also have this mobile science lab, which is a partnership between CSIR and National Council of Science Museum, which will go across Telangana and talk about genetic diseases, which is an initiative of CSIR CCMB. And sir, you may also be happy to know that the virtual lab which you launched, now the content has increased in this, so the work is ongoing, and Dr. Shastri mentioned our idea is to diversify this into multiple languages, which is we hope to be in the next 1 year or so in at least 5 to 6 languages, because India is a vast country and reaching each and every corner is important. And as a part of the diversification, to include the Divyanjan students today who are here, as you can see, some of them, much of the content, some of it has also been translated into Indian Sign Language, because innovation can come from anywhere. When you talk of SDGs or G20, we are all talking of inclusion. And I think this is a first step towards that. And Honorable Minister also announced the Jigyasa Vigyan Mahotsav winners as a part of the Azadi Ka Amrit Mahotsav, which was again done through the Jigyasa Virtual Lab. So, Dr. Shastri mentioned, we are also working with the Royal Society of Chemistry, and within NPL, last year we did this event. More than 2,000 students across the country took part in the coin battery experiment. The same experiment was done where Dr. Kalai Selvi was also there. So these are the initiatives. And coming today, so now today we have developed this Jigyasa mobile app. Although we have portal for the ease of connecting, like just now Dr. Venugopal mentioned, even I was not aware that 300 schools are connecting with NPL, being CSIR. So how do people come to know about the programs? Now when you have all these students, everybody wants to know. So I think this app is a great platform for them to connect to the students. And we have 37 CSIR labs. So this will be a one-stop solution for the student to connect and know what programs are there. Can they visit a lab? Can they schedule meeting a scientist? So we hope that this will really take us far. And this is again in partnership with IIT Bombay, who has been a great partner for our virtual lab. And the first of its kind in the country, we have set up an astronomy lab in Karnal, which happens to be the birthplace of the astronaut Kalpana Chawla. And so this is the first Indian Sign Language and enabled astrolab. Again, this is an initiative of two motivated individuals. Astrolab has been set up by Aryan Mishra, a young student who has gone on to set up these astrolabs in the country. And I have visited myself in Bulandshahr. Bulandshahr has more than 200 astrolabs, and they have a district astronomy policy, which is really a great thing. And so this in Karnal is enabled with Indian Sign Language videos and audios, so that these Divyanjan students can actually take benefit of this and also develop scientific temper. This will also be inaugurated by the Honorable Minister, and this is in partnership with CSIR-NPL. So, and this would not have been possible without the guidance of leadership of Honorable Minister, DG CSIR, and our three great partners, URIDIP, IIT Bombay, IMTech, and many other organizations. And special thanks to CSIR-NPL for hosting us today. Thank you.
Thank you, ma'am, for providing us with this overview. We truly acknowledge your hard work, determination, and perseverance for student-centric initiatives. After the clear overview, the time has come to witness the significant milestone of the launch of student-centric initiatives. I humbly request our Honorable Minister to kindly launch CSIR HRDG's student-centric initiatives. The first in the launch of CSIR button is pressed and the portal has been dedicated to the nation. The CSIR Yuva, an online application portal, is developed to ease out application process and make the system more transparent and efficient. The second initiative to be launched is the CSIR Jigyasa mobile app. I humbly request Honorable Minister to launch the mobile app for the students. The third initiative is the virtual launch of Indian Sign Language enabled astronomy lab for Divyangjan students in Karnal. I humbly request Honorable Minister to virtually launch the Astro Lab and dedicate it to the upliftment of the Divyangjan students.
More than 6 million deaf people in India use ISL. However, STEM subjects are not accessible for them. We welcome you to the ISL-enabled Astro Lab. Deaf children, like hearing children, gaze up at the night sky with wonder. The Astro Lab features over hundreds of videos with a focus on astronomy, but also physics, chemistry, biology, biopics and fun fact posters. This project is a joint initiative of CSIR Intech Chandigarh and HWS PSHI. We hope that you all learn and enjoy the wonders of science and astronomy.
I once again thank our Honorable Minister for doing the honors and dedicating these student-centric initiatives for the nation. We truly believe that these student-centric initiatives will promote the students and ultimately work for the upliftment of the society. I am highly honored to invite the visionary behind this 1 week, 1 lab campaign, who has played a vital role in shaping, encouraging, and promoting CSIR labs incredibly. I humbly request Honorable Dr. Jitendra Singh Ji, Honorable Minister of State, Ministries of Science and Technology and Earth Sciences and Vice President CSIR to kindly come up and share the pearls of wisdom with us.
On the dais, Dr. Shastri, Professor Venugopal, Professor Ram Gopal, Dr. Venugopal, our host, Dr. Geeta, seated before me, directors of different CSIR institutions, senior members of the faculty, dear students, ladies and gentlemen. This is a historic venue where we have gathered this morning. This is a place which has seen history being made not once but more than once. And I'm glad today we are making another historic landmark. Beginning from early 1940s, this is one of the first CSIR labs to have been set up in this country. The first one being in Jammu by Sir Ramnath Chopra, and this one, I think, around the time of independence. And also, if you may recall, if you have forgotten, you may bring back to your memory, this is one of those CSIR labs which was personally visited during the inauguration by the then first Vice President of CSIR, none other than Dr. Sama Prasad Mukherjee. Because he was the Vice President only for about 2 years before he put in his papers. But that also is a part of history, and we do have photographs in the corridor. Also, this is something which Dr. Venugopal would have told you, but I am performing his task on his behalf. This is also the laboratory which has evolved with the evolution of independent India. So the journey of NPL coincides with the journey of independent India since 1947. And that too in more ways than once. As he told you, the old timers would recall, whenever you heard the 8 o'clock bulletin in the morning, that was the only thing available at the 9 o'clock. That beep which he was referring to is one which emanated from this place. The atomic timing with which all of us used to match our watches, much before the electronic means came in. So in other words, the journey of NPL also coincides with the journey of Akashvani, which was the name adopted after independence. Thirdly, I think the electoral history of India is deeply indebted to this. If you didn't have this lab, maybe I wouldn't have been there. The reason being that right from the very first election that we have in this country in 1952, it was this lab which was providing that ink and saving many of us from bogus voting or helping others to indulge in the same. So you can understand how deeply embedded is this institution with the history of independence, the journey of post-independent India, the evolution of Akashvani and the news methodologies in this country, as well as the growth of electoral mechanism over the last 7 decades. And therefore, now why I'm saying all this is that this is precisely which prompted me to think of this. Not now, because incidentally I didn't have the mandate then, but about many years back, about 15 years back or about 10 years back, I was sitting with some of the friends from the tourism department. I said, what all about is that is done by you? He said, we promote tourism. We guide the foreigners to places where they ought to go. I said, now, because I am a Khurafati researcher like many of us, so I said, can you just tell me some of those places? Then he looked back at me with certain amount of disdain and contempt, as if I was trying to be over smart. So I said, do you permit me to tell? He said, okay, go ahead. I said, anybody coming to Delhi will spare 2 hours, 3 hours to go to Agra to get a photograph on the Diana bench, which I need not tell, you need not tell. Right from the day he begins his journey from the United States, he has to make a visit to Taj Mahal, seated himself along with spouse or maybe anyone else on that bench. No, I just mean that, not more than that, because the youngsters are having a laugh, and get a photograph. Then when the same tourist or the group of tourists arrives in Delhi, you don't have to tell him to visit Red Fort. That he knows, because so imposing is that red stone monument. Then you don't also have to often tell him about Jantar Mantar, because there's so many stories hanging after that, that the earlier times, this is how the time was detected when there were no other means, etc., etc. Then maybe a foreigner will also like to visit Qutub Minar, particularly if he happens to be France, a French tourist, just to make sure that it is not taller than the Eiffel Tower. So I said, then what else is what you guide for? And so much of resource, because I was luckily not part of the government that time, so I could, you have all these liberties. I said the active role or a contribution of any tourist guide or a tourist department or tourist agency is to acquaint people with the monuments of modern India. One of which is this, and I actually quoted this as an example. And they looked back quite blankly about what I was talking about. I think many of those friends were not even aware of what NPL meant or what it spelled out. So I told them, we have National Physical Laboratory over here. We have some of the institutes which have already, we have, for example, the IIPA's, Indian Institute of Public Administration, which was born just after 4 years after independence in 1950-51, one of the earliest institutes of administration. Of course, the other institutes came a little later, but just within the 5 years, we had some of the initiating monuments, which actually became a model for the other monuments to be brought up. And therefore, soon after this, government came in 2014, because I didn't have any access to them, nor the mandate to suggest them, because that was not part of my portfolio, but I had the Department of Atomic Energy. So I told the friends there that there are only 2 departments in Government of India, which incidentally do not have their headquarters in the national capital. And for legacy reasons, nobody asks, not even in Crorepati, is this ever question asked. I think this is a question which should fetch 1 crore. If the national capital of India is Delhi, why not headquarter of atomic energy in Delhi? If the national capital of India is Delhi, why not headquarter of Space Department in Delhi? Many of us think this is irrelevant talk. And that's because the eyes see what the mind knows. And you have to, if you have seen and the mind knows, then you can share with others. We had to set up the Department of Atomic Energy because the entire setup was done by Homi Bhabha in Bombay. And he started off just before independence actually. He had just come on a holiday and the World War started. He had to go back, he was on a leave, he could not, because all the transport was suspended. Most of the transport those days happened through ship, the sea route. It got suspended for 3-4 years as long as and the World War lasted till 1944. so he couldn't go back. Meanwhile, he started all this. And then soon after, the independence happened. And that gave a boost and supplementation to whatever he was doing. So by legacy, it got headquartered there. Similarly, Sarabhai was attending a conference in Trivandrum. Suddenly, he passed away in the middle of night. There was chaos the next morning. Nobody knew who would take over the Department of Space. ISRO had just been set up. So the only other person they could think of is the other person who had actually started the journey along with him was Professor Satish Dhawan. But Professor Satish Dhawan was so deeply rooted and settled in Bangalore that he could not left it. He had thesis projects, he had students, because he was into full-time work. He did not know that he would have to take over. So the department had to be set up in Bangalore. So what I did was that we set up in Pragati Maidan a hall of nuclear power. I'm saying so because I'm sure in this room nobody would have visited that. That has existed there for the last about 10 years, soon after this government came in. Sometimes we encourage the students to go there. It's beautiful, it's worth seeing. I mean, they have just personified how the nuclear energy develops, how the ultraviolet rays comes, how does it emanate, and there is also computerized question answer section there. So we set up a pavilion there. I suggested to Department of Space, we could be setting up the same there also. So thereafter, when I came to this department, I thought we could actually celebrate not only what we have done, but also make others aware for the reason that they are the stakeholders. After all, what are we working for? So this 1 week, 1 lab is actually meant to serve more than one purposes. A, to have your own esteem. Because if you are left isolated, you tend to lose your own esteem. You don't even like to shave in the morning. Recently, Hopkins started a project, appearance project for scientists. So that when you get up in the morning, make sure that you appear good. Otherwise, many of them would think that nobody is going to visit my lab, nobody is going to come here. How much difference does it make whether I go there bathed, unbathed, odorful or odorless? And actually, they started a project. But why do we have to come to that pass? So A, it gives us esteem. B, our stakeholders. As you were saying, Geeta was also saying, the students, the stakeholders, the industry, they don't know. And being students of science, we've been taught to speak not without evidence. And I can quote you so many examples out of the 37 labs. These labs or institutes are not even introduced to the similar institutes in their own vicinity of 4-kilometer radius. I think the simplest example is that we were sitting in IIIM Jammu, and as Professor Ram Gopal and Dr. Venugopal also said, each of these, I think Venugopal was saying, each of these labs is dedicated to a separate specialty or separate stream of work, which itself is a uniqueness. In this era of specialization, super specialization, now we are moving into sub-super specialization. You know, even in medicine, like the other days, Sadhguruji of Bangalore was telling me he had gone to Australia, he hurt his knee, so he told the hotel management, I need a doctor. He says, after 10 minutes, I received a call. They asked me, what is wrong with your knee? I narrated the story. Then they further started asking me. The lady kept on questioning me. He says, I got fed up and I told her, ma'am, in any case, the doctor is going to come. So why are you putting me into all this? She said, no, I have to determine what kind of orthopedic surgeon do you need. We have a separate orthopedic surgeon for trauma, a separate one for arthritis, separate one for nodular disease. So he says, I got so irritated. I said, now will you ask me which knee, left or right? But there is so much of knowledge explosion happening, and the doubling time, as we say in science, doubling time is the time when our textbook requires a fresh edition. It's also narrowing down. The volume of knowledge is increasing, the volume of information. And we, luckily, our founding fathers had this vision to set up each of these institutes dedicated to a separate stream, which again we are not being able to publicize enough. And the working in isolation, I was telling referring to the example of triple IM, I was sitting there and Dr. Reddy was telling me that we have an ambitious project because that lab is dedicated to drugs. It's the oldest drug research laboratory in India. So he said we are working on an ambitious project of multi-drug resistant tuberculosis. And I got him a project for cannabis before I was a minister here, through my own efforts, because that was part of my diabetes profession. We had a lot of diabetic painful neuropathies. So we got a project of cannabis cultivation. We had to get approvals from the government and a French collaboration. So he said there are two. Incidentally, it occurred to me that just 3 kilometers away was a postgraduate medical institute, a government postgraduate medical institute. And I said, have you got in touch with us? He said, no, we are not known to each other. So I sat there, made it a point to call the dean from there, who happened to be a lady. She was kind enough because we were calling at a short notice. So I said, no, because I may not get an opportunity like this. So she took over an hour to come, so I kept sitting. Then I suggested, I said, why can't we have a thesis? You have postgraduate students. Now for this drug resist, which is being the trials going on tuberculosis, can't you have a thesis in pharmacology? You have MD pharmacology. UGC guidelines say that the main guide has to be from the parent institution. The co-guide can be other. So I said, you have your professor as the guide. Let one of our senior scientists here be the co-guide, so that your boys, our boys, have an exposure to also move among the patients on whom they are actually going to ultimately use the drug. And I was told recently, I asked, and they were told that they have now actually planned that. Or similarly, even in medicine department, we have postgraduates, we have thesis, we have post-scholars there. So that is the magic, the advantage of integration. Similarly, in the Nagpur lab also, we hardly integrate even with those institutes which are doing a like-minded work. Whereas the need of the hour is to have an extended integration even with the industry. Like for example, you have some of the best labs, or one or two, you have the National Chemical Laboratory in Pune. At the same time, we have a huge pharma industry in Pune, so also in Ahmedabad. I was talking of the multi-drug resistance incidentally. Whereas the medical institute is 3 kilometers away, about 10 kilometers away is the Sun Pharma factory. So if you are actually going to now, through this Yuva portal, the idea is to connect, to identify the potentials, young boys and girls who could be startups, who could carry forward the torch. But how would you sustain them unless you engage the industry? And therefore, I think the idea is that every week, I'm glad that it has taken off quite well. It was being quite appreciably discussed the other day, even when I was in Hyderabad, because that laboratory also was observing that time. And there was some confusion in the beginning. We started receiving calls. Whom to call governor, to call vice president, to call chief minister, or to call which minister? So I had to tell them, no, we have to call ourselves. We are celebrating ourselves. We are celebrating our work. We are trying to realize the worth of our work, the reach of our work, and all those who are connected to our work, so that we can give extended life to our work. And therefore, these boys and girls are the ministers, the governors, and the chief ministers. So the initial two programs, it took us time, because they thought maybe another Sarkari program has been launched, as usually the ministers do. But the problem with me is that I go as chief guest, come back delivering a keynote address. Well, that is what I did for more than a quarter of a century. So this is the idea, is that when we propagate ourselves, and we do so not only through these programs, we use social media, which is the most common, we at least make people aware of what is happening here, so that they would come here not for us, but for their own reasons. The huge startup boom in this country, we are now number 3 ecosystem. And to sustain the startups, you need aptitude. So how to identify? Very often, we are providing support to those who reach us. They know where is the office of the Technology Development Board. They know where is the office of BIRAC. They have nothing else to do for the next 6 months. They take up a project. But are we reaching out to the one? So that is, I think, one huge challenge. So portal like this can enable us to reach out to those, A, who has aptitude, then to sustain, B, you have to connect him or her with an attractive source of livelihood. Because after all, that boy or girl they are the children of the same society. So he cannot tolerate for long his counterpart moving in a car and he carrying launcher on the carrier of his bicycle, which Zarabai did in those days, but won't happen now. So B is that. And third is to connect him with the industry. We could even do the industry mapping. And I'm glad that Dr. Venugopal was talking about the skill part of it. And of course, essentially startup is skill, innovation, creativity. And most of all, we are going to launch another program very shortly. I have some ideas in mind to do a follow-up of the startups. I mean, it sounds a little unpleasant, also a little rude. Because अब मुझे support दिया तो you are going to follow me up? Yes. We have a count of startups. We don't have the count of who actually ended up as startups. How many of, and that could be an education for us. So in the next meeting that we have a combined scientific departments meeting that we have started the process only this year. I have requested a presentation. We have certain models. One of the models emanated from America, where they actually make phone calls to the startups or reach out for them physically every year to see what they are doing. So if we are able to do that, we would not only be able to improve upon ourselves, but also able to. And third, I think what we have started today, the first ever lab in Karnal, is a huge, huge message that we are providing a level playing field. And that is directly connected with aptitude. Aptitude may not be correlatable. You cannot correlate it with your physical attributes. A person who is physically challenged or physically blessed may be having greater aptitude. Like Wordsworth says, there is a man who walks through the world with eyes open and the other one who walks with the eyes closed. But both are blessed with the eyes. They are not Divyangs. So we will give preference to aptitudes, to the caliber, to the capacity, to the inherent urge, rather to the physical attributes. That's also the message which has gone loud and clear from the platform of CSIR today. I once again congratulate you. I think this Yuva portal will help us to connect, to identify the potential student startups, young startups, and also very soon when we develop a mechanism to follow them up, we'll be able to do them house handling, home handling, or hand holding even in midway, because I've seen many of the women startups dropping out for reasons of wedding. But if one of us comes to know, you could at least come to their rescue and find an option. We had a scientist in Bhopal lab, she dropped out because she got married to an IAS officer. So I don't know which is better, IAS or scientist, that is for you to decide. But nevertheless, so we will not have, we may contribute in preventing such casualties happening. These are casualties happening to the scientific fraternity if we are able to follow up. And this is one step towards that. The Yuva Portal and the level playing field to pick up the aptitudes is our Karnal initiative. So all the very best, and I'm sure this is going to, at the end of the day, benefit each one of us who have a stake in this. Thank you.
Thank you, sir, for your golden words. It is an honor and delight for us to hear you speak. We are fortunate to have you as the anchor and shield of CSIR. Thank you, sir. This time, I would like to request our Director NPL to kindly felicitate Honorable Dr. Jitendra Singh Ji by presenting him a shawl as a token of gratitude. Muskan and Priyanka, I request you to kindly bring it. A heartfelt thanks to you, Honorable Dr. Jitendra Singh Ji, for being the fountainhead of illuminating ideas and for your dedicated pursuit to public service. Thank you, sir, for doing the honors. As we have come to the end of the program, I would like to call upon Dr. Ritu Srivastav, convener of One Day, One Week program, Senior Principal Scientist NPL, to propose a vote of thanks.
Good afternoon to all. It's my privilege to propose a vote of thanks. On behalf of Organizing Committee of CSIR-NPL, One Week, One Lab campaign, and on my own behalf, first of all, I would like to thank the Honorable Minister of Science and Technology and the Vice President of CSIR for kindly consenting to inaugurate this event. Thank you, sir. Thank you, sir, for gracing the event and for your motivational speech. It will guide us to meet the expectation of the government policies. I would like to thank our DG ma'am for her constant support. Due to some health issues, she is not able to join us today. Our sincere thanks to today's keynote speaker, Professor Ram Gopal Rao, Group Vice Chancellor, Birla Institute of Technology and Science, for sharing his innovative research ideas. Thank you very much, sir, for accepting our invitation to deliver a keynote lecture. I would like to thank Dr. N. Sastry, Director NEAST and Chairman Jigyasa Task Force for delivering the vision and future roadmap of Jigyasa. I would like to thank the head CSR HRDG, Dr. Geeta Bani Raisam ma'am, for giving an overview of the CSR HRDG student-centric initiative. I would also like to express my gratitude to all the distinguished invited guests, dignitaries from CSIR headquarters and other lab and institute, our former director and retired scientist and media person for attending this event. I want to extend my generous thanks to Director CSIR-NPL, Professor Venugopal Achanta, for his guidance, constant support and encouragement. I would also like to thank all HODs, my support service departments, my NPL colleagues and ACSR students for their active participation. I am thankful to all the participants, students and teachers from different schools and the young students for attending this event. On behalf of HRDG, I would like to thank all the people who are involved in the development of the CSR Yuva portal, the Jigyasa mobile app and Astrolab. I am thankful to our organizing team for their hard work to make this event successful. As this list is very long, it is difficult to name each and every one. Once again, thanks to all the people who helped either directly or indirectly to make this event successful. Thank you all. Our dear Divyangjan students would also like to present a memento as a token of gratitude to our Honorable Minister. I invite them on the stage. All the mementos that they are offering are handmade.
Can we have a huge round of applause? A huge round of applause for our Honorable Dr. Jitendra Singh Ji for being the fountainhead of such illuminating ideas and for his dedicated pursuit for the public service. We are humbled and honored for your benevolent contribution. Thank you, everyone. Please be seated on your respective seats. On the demand of our media partners, there is a special photograph of our esteemed dignitaries. Thank you so much. I request our esteemed dignitaries to kindly be seated on the dais. Thus, the entire team of Jigyasa Thank you so much. I request our esteemed dignitaries to kindly be seated on the dais. Now, as the curtains draw to a close, we have come to the end of today's program. But as we embark the journey of 1 week together, we have a series of events lined up for you all, so please stay connected. So as we conclude, let us all rise up for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you, everyone. Our guests can proceed for the lunch towards the food court. And our venerated guests are requested to proceed towards the VIP lounge.
गाड़ी का गाड़ी में बाहर था मैंने नंबर दिया तो अभी लेके जाना बाद में जरूरत दे दी सब वो गाड़ी में सर गाड़ी में अच्छा ढूंढ लेके आप दे देते हैं